Good afternoon, class. We are looking at Chapter 7, Systems of Equations and Inequalities. Here's Section 7.3, Systems of Nonlinear Equations and Inequalities. So we've covered systems of linear equations in 2 variables, 3 variables, and now systems of nonlinear equations. The objectives are: solve a system of nonlinear equation using substitution, same thing using elimination, graph a nonlinear inequality, graph a system of nonlinear inequalities. So here's the synopsis of what we covered: systems of linear equations, a group of 2 or more equations. They can be solved by graphing, substitution, or addition method. Types of system: a system of 2 linear equations in 2 variables can have 1 solution, no solution, or an infinite number of solutions. An inconsistent system is the system that has no solution. The graphs are parallel lines. They have the same slope, but different y-intercepts, as you can see it from the graph here. Here's the equations. If you were to solve them for y, as it is the case here, you see they have equal slopes, different y-intercepts. If you were to do it by substitution or elimination, you end up with a contradiction such as 0 equals 7. Indicates the system has no solution. The system is inconsistent. A consistent system with independent equations. The system has a single solution at the point of intersection. The graphs are different. They have different slopes. So as you can see, the point of intersection is the solution. And if you were to solve for y, you will find that they have different slopes. Consistent system with dependent equations. The system has an infinite number of solutions. The graphs are identical. They have the same slope and the same y-intercept. So if you were to graph them, they coincide, they be at top of each other. And if you were to solve for y, they become identical. Not only M1 and M2 are equal, also B1 and B2 are equal. And if we were to solve it by any method like substitution or elimination, an identity such as 0 equals 0 indicates the system has an infinite number of solutions. The equations are dependent. Now, what happens with the 3 variable? We have a similar situation. Types of systems: a system of 3 linear equations in 3 variables, similar to system of 2 linear equations in 2 variables, can have 1 solution, no solution, or an infinite number of solutions. The equation 2x minus 3y plus 4z equals 8 is an example of a linear equation in 3 variables. The solution to this type of equation is an ordered triple of the form x, y, z. Now, a consistent system of equations with a unique solution, a single solution. If the planes intersect at a single point, that ordered triple is the solution to the system. There's 1 point of intersection. A dependent system of equations, infinite number of solutions. If the 3 planes intersect along a line, the system has an infinite number of solutions, which are the coordinates of any point along that line. If all 3 graphs are the same plane, the system has an infinite number of solutions, which are the coordinates of any point in the plane. Example, you would obtain a system that is always true, such as 0 over 0. So this all 3 planes are the same. In this case, they intersect at a line. An inconsistent system of equations with no solution. If all of the planes are parallel, the system has no solution. Pairs of planes also can intersect as shown. However, because all 3 planes do not have a common intersection, the system has no solution. Example, you obtain a statement that is always false, such as 3 equals 0, if you go through the process of solving. And now 7.3, nonlinear system of equations. A nonlinear system of equations is a system of equations in which at least one equation is not linear. That is, one whose graph is not a straight line. As you can see, for example, this is a parabola, this is a line that makes it a system of nonlinear equations. There's no point of intersection, there is no solution. A parabola and a line, if they have one point, which is an intersection of the two, we can have one solution. If the line goes through it and we have 2 points of intersection, there are two solutions in this case. Solve nonlinear system of equation using substitution. Here's what we have: x squared plus y squared equals 20, y minus 2x equals 0, and this is a circle, this is a line. So clearly the easy way would be to solve for y, which we get 2x. So if you call this equation number 1, equation number 2, and this one equation number 3, you are going to put that into the first equation. Becomes x squared plus y squared is replaced by 2x, everyone. We get x squared and 2x squared equals 20. Now this is 4x squared. They add up to 5x squared. We're going to divide by 5, results in 4. X squared equals 4 has two solutions, namely plus minus 2. So we can substitute it into this one. This is practically the same thing. And we'll see that if we do so, we get the answer for y, which is 2 times x. So if it's either one, we get plus minus 4. So if it's 2, is 2 times 2. If it's negative 2, is 2 times negative 2. And therefore, we get 2 and 4, negative 2 and negative 4 as the solution, everyone. Notice if we were to graph them, we would get a circle. X squared plus y squared equals 20 is a circle centered at 0, 0 with the line y minus 2x equal to 0, which goes through the origin. And those are the 2 points of intersection, everybody. Example 2, solve this system: 3x squared plus 2y squared equals 66, 2x squared minus 2y squared equals 14. We are solving nonlinear system using elimination or addition. In fact, even if they don't mention it, we should recognize that all you have to do, because these two are opposites, just add up each side. So we add these two, cancel each other. This becomes 5x squared. This becomes 80. Divide both sides by 5, you get x squared equals 16. X is plus minus 4. You put the x equals plus minus 4 into one of the original equations. And you may notice, by the way, that this one, everybody, becomes x squared minus y squared equals 7. You can divide this by 2 and put it into that. It's practically the same thing, everybody. Again, I hope you recognize that you can simplify it in this manner. You don't have to, you can go with the original one, but this makes it a tad faster. And when we put it in, we get plus minus 4 quantity squared, which is 16, minus y squared equals 7. We're going to move things around by moving it this way, results in minus y squared equals 7 minus 16 minus 9. We are going to divide by -1. Y squared becomes 9. And y is plus minus 3. Very straightforward, everybody. Before we continue again, we could have done this division and worked on it here, but it actually was easier to deal with what was given. This one is your choice. So the system has x equals plus minus 4 as a solution, y equals plus minus 3 as a solution. This creates 4 solutions, positive 4 and positive 3, positive 4 and negative 3, negative 4 and positive 3, negative 4 and negative 3. And since we use the second one to come up with the solution, you must use the first one to check. So if we check one of them, for example, 4 and 3, this will give us 3 times x, which is 4 squared, plus 2 times y, which is 3 squared, and the answer should be 66. So this is 16. This is 9. 3 times 16 is 48. 2 times 9 is 18. And it checks. And you can do the rest of them in the same manner, everybody. Okay, it's a pretty straightforward. I hope everybody's okay with that. All right, let's look at an application problem. Given that the rectangular area of 48 square feet along the river bank, as illustrated, find the dimensions if 20 feet of fencing is needed. So we have the width of x, the length of y, and the 20 feet of fencing is x and x, 2x plus y equals 20, and area of 48 means x times y must be 48. So we can solve for y here. Becomes 20 minus 2x. We can replace the y here with 20 minus 2x becomes x times 20 minus 2x equals 48. If we distribute we get 20x minus 2x squared. And we're going to take everything to the right because we want 2x squared to have negative 2x squared to have a positive coefficient. Therefore, we move it this way. This becomes positive. This becomes negative. So 0 equals 2x squared minus 20x plus 48. To factor this, we are going to factor the GCF, the greatest common factor of 2. So we get 2 times x squared minus 10x plus 24. We want two numbers. The product is 24. The sum is negative 10. So those are negative 4 and negative 6. When we set this equal to 0, x is either 4 or 6. So if x is 4, and remember, you have to put this back into one of these. If you put it into this one, for example, x is 4, 48 divided by 4 is 12. If you put it into this one, 2 times 4, 8, subtract, or to this one, and subtract it from 20 is 12. So for 4, we get 12. If you plug in 6 here, 6 times what number is 48? It's 8. If you put it here, 6 times 2 is 12, subtracted from 20, again 8. So there are two sets actually. It could be 4 along with 12 or 6 along with 8. That means 4 by 12, 6 by 8. So there are two sets. Either this one, the dimensions could be 4 by 12 or 6 by 8. And a quick recap so we understand what happens. The area for both of them, 4 times 12 is 48, 6 times 8 is 40. So the area works. The fencing, okay, it's, remember, 2x plus 1y, okay? So 2 times 4, 8 and 12 is 20. 2 times 6, 12 and 8 is 20. So you should check, and we just did, everything works out. A gate is shaped like a right triangle with a perimeter of 36 meters and a hypotenuse of 15 meters. Find the length of the legs of the triangle. Well, first of all, we have everything here. The legs are A and B, and the hypotenuse is given as 15 meters. So let's put it there. The hypotenuse is 15 meters. The perimeter is 36, so they add up. A plus B plus C, and C is of course 15, must be 36 on the one hand. On the other hand, the Pythagorean theorem says A squared plus B squared is C squared, which is 15 squared. So this one, the perimeter is 36. Add up the sides, and one side is given as 15. And this one is Pythagorean theorem. Pythagorean theorem. So to solve this, we're going to use it. By substitution. So we're going to solve for either A or B and put it in here. And if you want to solve for B, you are going to take A to the other side, 15 to the other side. So you get minus 15 minus A, and B becomes 21 minus A, because 36 minus 15 is 21. So we are going to replace the B with 21 minus A. And of course, 15 squared is 225. We're going to simplify this by raising it to the power of 2. So 21 squared, which is 441, minus 2 times the first times the last, minus 42A, and then A squared. So this one remains. And 21 minus A quantity squared becomes 441 minus 42A plus A squared. So we are going to combine these two into 2A squared. And at the same time, we are going to subtract 225 to make everything, to set everything equal to 0. We bring everything to the same side, everybody. So what do we get? We get A squared and A squared, 2A squared, minus 42A, and 441 minus 225. They combine into 216. You can use factoring, you can use the quadratic formula. Obviously, there is a common factor of 2 we can take out. That gives us A squared minus 21A plus 108. Then we want two numbers. The product is 108. The sum is negative 21, which makes both of them negative, and negative 9 and negative 12. So A is either 9 or 12. So you can say A is 9, B is 12, or you can say A is 12, B is 9. The fact of the matter is the dimensions are 9 and 12. One of them is 9, one of them is 12. That's the idea. That's why we get two sets in essence. But it's really one possibility that one of them has to be 9, one of them has to be 12 in any order. And you can check if you go with 9 and 12, 9 and 12, 21 and 15 is 36, 9 squared and 12 squared. 9 squared is 81, 12 squared is 144, 15 squared is 225. So when you add them up, you do get that. So you really have to check always to be on the safe side. Solve the system of equations. In this case, you really don't have to do much. We are going to do by elimination clearly because these two can cancel each other. And we end up with 3x squared equals 3. We are going to divide by 3 both sides. X squared becomes 1. And x is plus minus 1. X is plus minus 1. So it's pretty straightforward, everybody. As far as finding x. Now, what happens is we are going to use one of these original equations to find the missing y, and all you have to do, this is the easiest way, by the way, plus or minus when you raise it to the power of even makes no difference. So let's go with the first one. This will give us 1. Subtract from both sides 1, and you get y squared equals 8. Y clearly becomes plus minus square root of 8. Eight is 4 times 2. 4 comes out as 2. 2 remains, so plus minus 2 square root of 2. These are precise answers, everybody. We're going to keep them as precise. And I hope you recognize there are 2 answers for x, 2 answers for y. There are a total of 4 solutions. Positive 1 with positive 2 square root of 2. Positive 1 with negative 2 square root of 2. Negative 1 with positive 2 square root of 2, and negative 1 with negative 2 square root of 2. That's how we arrive at the answer. And as I mentioned, you've got to be very careful to make sure you have the correct answer. Now, what did we do? We used the first equation to come up with the y. You have to use the second equation to check. So what I'm going to do, I'm going to use one of these. In fact, let's use this one. And I'm going to call this equation number 2. We are going to check one of them. So that means 2 times x, which is negative 1 squared, minus y, which is negative 2 square root of 2 squared. And is this equal to negative 6? I hope you recognize this one as 1. And again, negative or positive makes no difference. When you square this, you get 8. 2 minus 8 equals minus 6. It checks. You can try the others as well. And by the way, remember, 8 gave us plus minus 2 square root of 2, right? So it's the reverse process. So we just checked it. And that's the beauty of math. You can always check your work. Solve the system of equations where x squared plus y squared is 25, 3x plus 4y equals 0. Because this one is of degree 2, this one is not, the best course of action is by substitution. So you should recognize which method works the best. So either you solve for y or x makes no difference. If we move this, becomes negative 3x. If you divide by 4, y becomes negative 3/4 x. Now we are ready to move on with the first equation. X squared, so be it, and replace the y with negative 3x over 4, raise it to the power of 2 equals 25. You are going to solve this equation. So x squared is fine. This one is plus 9x squared over 16, and the right side doesn't change. The best way to solve an equation involving fractions would be to get rid of the fractions. To do so, an easy way is to multiply both sides by the denominator 16. So when we do that, we are going to distribute here to get 16x squared. When we distribute here, this goes away, we get 9x squared. And the product of 16 and 25 is 400. 16 and 9, 25x squared. Divide both sides by 25, and you get 16. X squared is 16, and x is plus minus 4. So again, Very straightforward, everybody. Now we go back to either this one or this one. It really doesn't make much of a difference. If I plug in 4 here, this 4 cancels out this 4, and I get -3. So plug in 4, 4 cancels out the 4, I get -3. If I put -4, cancels out the 4 and gives me -1 times -3, it gives me +3. So we have 2 possibilities for x that creates 2 solutions. Either +4 goes with -3 or -4 goes with +3. There are 2 sets of solutions. And remember, we use this one to get to the answer. You have to use the first one. I'm going to call it equation number 1, everybody. And I'm going to check one of those. For example, this one, and I get 4 squared plus -3 squared. And I ask myself, is this equal to 25? I get 16 plus 9 equals 25, and it checks. Solving systems of linear inequalities, graph each inequality on the same axis. The solution is the set of points whose coordinates satisfy all inequalities in the system. As an example, let's graph the solution set for the system of inequalities here. So we have x plus 2y is larger than 5, y less than 3x minus 2. And you first graph the line. No matter what you have, greater than, less than, or equal to, greater than, or equal to, you go with the equality. So we're going to graph the first one, x plus 2y equals 5. And I'm going to go through the intercepts pretty fast. When x is 0, y is 5 halves. When y is 0, x is 5. I'm going to assume nobody has any problem understanding intercepts. So you can plot the 2 points, 0, 5 halves, 5, 0, and graph a line. And then we change the line to a dashed line. Why is that? This is just greater than, it's not greater than or equal. If it's greater than or equal, the line also is part of the solution. So it's not. So we are looking at just one of, never mind the second one, completely ignore that. So what do we do with this one? Now we are going to use a test point. Any point can be a test point as long as it doesn't belong to this line. And the easiest point, of course, would be what? 0, 0. As long as 0, 0 is not part of the line. So if you put it into this, 0 plus 2 times 0 makes 0 larger than 5. And 0 larger than 5 is a false statement. So if 0 larger than 5 is a false statement, 0 is not a solution. If 0 is not a solution, this side is not a solution. The opposite side is, and so you shade that region. We're going to do the same thing here. We're going to set this equal. And we're going to find the intercepts. If x is 0, y is -2. If y is 0, you put the -2 to the other side, becomes +2 divided by 3, so 2/3 0. And of course, you draw this line also, and this line is a dash line as well. I can't emphasize this enough because equality is not there. So we should recognize it as a dash line. So we draw the line simply by putting the intercepts 0, -2, a 2/3 0, and a dash line. And again, let's go with the same test point because this 0, 0 doesn't belong to the blue line either. So if I put 0 instead of y, 0 instead of x, I get 0 less than 0 minus 2. In other words, 0 less than -2, which is again a false statement. And that means 0, 0 is not a solution for the blue line either. So if 0, 0 is not, this side is not. The opposite side, that means this side is. Now, this shaded region is for the blue line. This is for the red line. Where do they come from? Notice we have two lines and 1, 2, 3, 4 regions. This is the one that has both colors. And this is the solution for the system of inequalities. Again, I want to emphasize that the two lines are dashed because we don't have the equality in either case. Graph the solution set for the system of inequalities where y is less than 3 and 3x minus y is greater than or equal to 6. Of course, you easily recognize that this, to get the solution for this, the line is y equals 3, which is a horizontal line. And you really, I mean, horizontal line, this is 0, 3, this is horizontal line. You don't need a test point. Y is less than 3. Anything below this horizontal line is the answer for the first part. And y is a dashed because we have less than. So we're done with the first part. The second part, we're going to take it to an equality, make it 3x minus y equals 6. We are going to come up with intercepts. If x is 0, minus y is 6, that means y is -6. And if y is 0, 3x equals 6, that means 2 comma 0. Again, finding intercepts by now should be a piece of cake. And so you can draw the line 0, -6 is somewhere here, 2, 0 is here, connect them. Why is this a solid line? It's not a dash line because we have the equality, everybody. Test point 0, 0. Because 0, 0 is not on the line, the blue line, that would be a good point. If I plug in 0, 0 into the inequality, I get 3 times 0 minus 0. 0 is larger than or equal to 6. No, it's not. It's a false statement. 0, 0 fails to be a solution. So this side is not. The side opposite that. This side is the solution for the blue line. And as you can see, again, you have two lines. Here's the point of intersection. We have 1, 2, 3, 4 regions. This is the region that has both colors come together, the red, or you can say purple and blue, and the solution is this region. Inconsistent system, graph the solution set for the system of inequalities where y is larger than 2/3 x plus 3 and 2x minus 3y is larger than or equal to 3. So we want to see how it works. So again, we are going to go with an equality. The very first one, we just change this to equality 2/3 x plus 3. And to graph this again, we're going to go with the intercepts. Clearly, 0, 3 is the y-intercept. And if I set y equal to 0, let's just actually show that. And then, so if I set y equal to 0, if I multiply both sides by 3 halves, the reciprocal, I get -9/2 equals x. And therefore, we have -9/2, 0 as the x-intercept. So you draw the line, -9/2, 0, that is -4.5003 is here. And the line is a dashed line again because we don't have an equality. Take a look, dash line because of equality. And so use a test point 0, 0 again. That would be a good test point because it's not on the line. If I put 0 here and 0 here, I get 0 larger than 3, which is a false statement. So therefore, 0 is not included. It's the opposite side. That would be the region. We do the same thing here. We set it equal 2x minus 3y equals 3. To find the intercepts, if x is 0, -3y is 3, or y is -1. If y is 0, 2x is 3, so x is 3 halves. And so 0, -1 is here. And 3 halves, that means 1.5 somewhere here. And you draw the line, and it is a solid line. The blue one is a solid line because, look, we have the equality. Now let's go with the same test point. That's a good point because it's not on the graph. If I put 0 here, I get 2 times 0 minus 3 times 0, 0 greater than or equal to 3. It is also a false statement. So this side is not a solution. This side is a solution. So what is the solution for the system? Nothing comes together. Okay? So there is no solution. But what is important for everybody to see is to check and recheck that for both of them, if you look at this equation, m1 is equal to m2 equals to 2/3. If you solve this, we're going to do that in a moment. And the slope is 3 for this one. The y-intercept is 3 for this one. The y-intercept is not 3 for this one. So let me quickly show you how this works. I'm going to solve for y because I want to find the slope and the intercept. So let me use a different color. So -3y equals minus 2x minus 3. We're going to divide everything by -3, everybody. And when we do that, the left side becomes y. And the right side becomes 2/3 x. This was plus 3, everybody. Minus 1. And that's why if you look at the two lines, both of them have the same slope, but different y-intercepts. And that's why the lines are parallel. Since the shaded regions do not overlap, there is no solution for the system. I can't emphasize this enough, everybody. To understand what happened, you really need to see that they are not overlapping, and that's really the idea. Okay. All right, we are going to move on to this question. Solve systems of linear inequalities containing absolute value. Recall, if absolute value of x is less than a and a is positive, larger than 0, then x is sandwiched between negative and positive a. If absolute value of x is larger than a and a is positive, then x is either less than minus a or larger than a. So for example, if you want to graph absolute value of x less than 3, okay, what happens here? Of course, we want to solve this, we want to graph this in a Cartesian coordinate system. This is Cartesian coordinate system, everybody. The reason we want to do it with the Cartesian coordinate system because absolute value of x less than 3 can be also graphed on a number line. Can be graphed on a number line. So Cartesian coordinate system. So x is sandwiched between -3 and 3, which means we have two lines. One of them is x equals -3, one of them is x equals +3. So I draw the two lines. Now, to answer that, both of these lines must be dashed lines. And the region between the two is the answer. So we make both lines dashed lines, and the region in between is the answer. So first I draw the two lines, then I mention why, because why are they dashed lines? Because we don't have the equality. We do not have the equality, everybody. Graph the system x plus y is larger than or equal to 3, x minus y less than or equal to 3, and we want to find the intersection of the region. So we're going to graph them one by one. So to graph the first one, in other words, let's say it was just one of them. Okay. So x plus y is larger than 3. First, we go with the equality. And I hope you see it's easy. The intercepts are x is 0, y is 3, y is 0, x is 3. So we have 0, 3, and 3, 0. And so here's 1 point, 0, 3, here's another one, and you connect them. And it has to be a dash line. It may be hard to see, but this is a dash line, everybody, because this is, okay, actually, this has the equality, so it becomes a solid line. This has the equality, everybody. So we do have the solid line because it was it did have the equality. I can't emphasize this enough. So greater than or equal, because this is greater than or equal. So it's a solid line. Now we go with the test point again. As always, 0, 0 is a good one if it doesn't belong to the line, and if you plug in 0 and 0 here, 0 greater than or equal to 3 becomes a false statement. 0, 0 is not a solution. This side is not a solution. The opposite side is. So by now we know that. So again, let me just show you. So if you plug in here, 0 plus 0 is 0 larger than or equal to 3. It's a false statement. F short for false statement. We're going to do the same thing with the second one, and we go with the equality. And if x is 0, y is negative 3, because negative y is 3. If y is 0, x is 3. So we have these 2 points. One is 0, negative 3, it's here. 3, 0 is here. And again, since we have the equality, it is a solid line, everybody. We go back to this easy point 0, 0, since it's not part of the graph, and we put it into the inequality. If I put this in here, I get 0 minus 0, which is 0, less than or equal to 3, which makes it a T or true statement. Therefore, 0, 0 is a solution. Everything on this side is a solution. Okay. Now, actually, we should draw it on the same set of axes. We put them together, and we notice looks like that. Clearly, the intersection of the region would be the answer. This one and this one. There are 1, 2, 3, 4 regions. We have like some, it looks like an X. This is the region that has both the blue and the red one coming together. So this is the solution set. A graph y is between -1 and 5. In other words, -1 less than or equal to y less than or equal to 5. It's important to know we are dealing with a Cartesian coordinate system. Otherwise, this can be done even on a number line. It goes from -1 to 5, and that's it. But this is dealing with Cartesian coordinate system. So in essence, I mean, in a short answer would be, okay, y equals -1 is this one, a horizontal line. Y is equal +5 is this one. And because y is between the two, anything in between is the answer. So clearly and quickly, you can see the answer. So if we want to go through the process, y is larger than or equal to -1, and y is less than or equal to 5. So this is y equals -1, and of course, we have the equality is a solid point, and y is larger than that. So the region above that. On the other hand, y equals less than or equal to 5, and the answer to that is anything below that. And again, this is a solid line, so everything underneath, so they come together in between. Or as I mentioned, just draw the two horizontal lines, y equals -1, y equals 5, and shape the region in between. It's very obvious, class. I hope you find this an obvious case. All right. We're going to graph the system of x minus y less than or equal to -2, x less than or equal to 3, y equals greater than or equal to -x. And those are easy to do with this one. If you go with the equality class, let's go with the one actually. So if x is 0, minus y equals -2, and y equals +2, so 0, 2. if y is 0, x is -2. So those are the pairs. Those are easy to see, I hope. And you can see this line. This is 0, 2. This is -2, 0. And the line is solid because it has the equality. X less than or equal to 3. Remember, x equals 3. This one is very obvious. It's a vertical line. So 1, 2, 3. So a vertical line here, x equals 3. And we say x is less than or equal to 3. By the way, it's this way. We're going to discuss that in a moment. But y is larger than or equal to minus x. I hope you remember y equals x is like that. Y equals minus x is like that. So the equality will give us y equals minus x. And that has only one intercept. 0, 0 is both x and y intercept. Okay. And then, for example, if you plug in x equals 1, y becomes -1. And so you have 0, 0, and 1. This is -1. It's hard to see that, but it's -1 class. This is, let's make this into a comma, 0. It's very hard to see that, understand that. So 1, -1. And so if you graph it, notice everybody, we have 0, 0 here, 1, -1 here. And so if you use the test point 0, 0, it makes it easy. And those are the points of intersection among those. We're going to discuss them in a moment. But the test point can be 0, 0. And what happens is that the solution is shown and the vertices are labeled. These vertices can be found by finding the intersection of the points of the pairs of lines. I hope you see that, for example, if you look at the blue line and the green line says x is 3. So this point is x is 3. So remember, you're going to go with x minus y equals -2. So if you put 3 here, 3 goes to the other side, becomes -5, y becomes +5. So this is 3, 5 as an example. Okay. Now, if you look at this line, y equals -x, if this is, let me just actually write this. So this is x equals, green one, let me use, x equals 3. So no matter what, x is equal to 3. And this one, what color do I use? Let's say red. This is y equals -x. Let me use a blue one. And this is x minus y equals -2. And so they come together, and you can easily find points of intersection. As I mentioned, if you put 3 into this one, you get 3, 5. If you put the 3 into this one, they are opposite of each other. So this one becomes 3 and -3. And if you work for this one and this one, okay, x minus y is -2. So you replace the y with -x and you get 2x. And you can figure out the point of intersection, which is -1 and 1. So you can easily find the answer. Again, so you put this one here, you get 2x equals -2. 2x equals -2, x becomes -1. And if x is -1, y, it's easier to go with this one, is +1. So those are points of intersection, everybody. And if you use a test point 0, 0, the region becomes in between. I'm going to leave it for you to show that, but just a quick checking. If you look at x less than or equal to 3 is this side. So I'm going to go with the arrows, everybody. So the green one. The green one, the answer is this way. The blue one, the answer is this side. You have to shade this region. And I'm not shading it because it can make it difficult when we have too much. And let me use a red one. And for this one, the answer is this way. And all you have to do is check with the test point. So if you put them all together, they come together in this little triangular shape. And this is used in applications a lot, especially the corners are important sometimes. So that is known as a feasible region. Find the solution and sketch the graph of y squared less than x plus 4. And again, we do the same thing. We set this equal. So we replace the less than with equal. This is the graph. You probably remember, we're going to discuss this with more details in later chapter, but you probably remember this as in intermediate algebra as a parabola that opens sideways because y has an exponent, and that's why it opens sideways, because the coefficient of y is positive, it opens to the right. So if you were to graph it, results as a parabola symmetric with respect to the x-axis and the x-intercept. If you set y equal to 0, you get -4. So you get -4, 0. And the y-intercept, if you set x equal to 0, you get y squared equals 4. So y is plus -2, you get 0, -2, and 0, 2. We will discuss this function. This is not a function, this parabola with more details later on. And so since the inequality is less than, it doesn't have the equality, it has to be dashed parabola. Now, all you have to do, basically, the answer for the inequality is inside or outside. So if you pick any point, one point, not on the parabola, for example, if you pick this point, -5, 0, and test it with this inequality, that shows you what's going on. So you are going to replace the x with -5 and y with 0. So y squared is less than x plus 4, 0 squared is less than -5 plus 4, 0 is less than -1. Clearly, this is a false statement. And -5, 0 is not a solution of the inequality. If the point which is outside it is not a solution, the opposite side, the inside, is a solution. But just to be on the safe side, you can even test a point inside. The easiest point would be 0, 0. And if you plug it in, 0 squared is less than 0 plus 4, 0 is less than 4. Yes, it is a true statement, and therefore 0, 0 is a possible solution. So inside is a possible solution. Again, you really don't have to do that. This is good enough to prove it. But just in case, I wanted to show you, you can check as long as the point you pick is not on the parabola. So points to the right of the parabola are solutions. So we shade this region, and inside the parabola, where y squared equals x plus 4, this is the answer, everybody. Finally, I want to mention this concept of linear programming and the constraints. Linear programming is a mathematical process of maximizing or minimizing the quantity subject to several limiting factors. In a linear programming problem, the limiting factors can be represented by linear inequalities called constraints. Here's a simple example. Jose is landscaping his yard with some trees and bushes. He would like to purchase at least 3 plants. The trees cost $40 and the bushes cost $20. He cannot spend more than $300 for the plants. Write a system of inequalities that describes what Jose could purchase, then solve the system by graphing. So we have plants, we have tree and bush, and we have the cost. So we set up a table. Plants are tree and bushes. The cost for tree, $40 for bush, for any bush would be $20. How many of each do we need? I don't know. How about X here and Y here? The numbers X and Y. And so we want to write the inequalities. So he would like to have at least 3 plants. These are the plants. So X plus Y must be greater than or equal to 3. On the other hand, the cost is $40 and $20. So 40 times X and 20 times Y. He cannot spend more than $300, must be less than or equal to 300. I hope everybody understands that. At least 3, X plus Y is larger than or equal to 3, and cannot spend more than 300. So 40X plus 20Y less than or equal to 300. So we can graph this line, setting it equal and having the pair 0, 3. I hope you recognize this with the y-intercept and x-intercept. So x plus y equals 3. And when you graph it, you get this line, okay, 0, 3, 3, 0. And the testing point 0, 0 is a good testing point because it's not on the graph. If you plug it 0 greater than or equal to 3, that is a false statement. This is 3, everybody. Okay, so that is a false statement. So that doesn't work. And because 0, 0 doesn't work, you shade this region. For this one, we're going to go with 40x plus 20y equals 300. If you choose x to be 0, y is 300 divided by 20, 15. If you choose y to be 0, x is 300 divided by 4, 40, 30 divided by 4, 15 halves, or 7.5. And if you graph the line, if you plug in 0, 0, in here, it makes it a true statement because 0, 40 times 0, 20 times 0, 0 is less than or equal to 300. Yes, so when we draw the line, everything below that is the answer. So I hope you see that for these two lines, things in between would be the solution. So the solution, any ordered pair in the overlapping region, this region, is a solution. Assuming that only whole trees and bushes can be purchased, only whole numbers would be in the solution set. For example, 4 and 2, if you look at this point, for example, just as an example. There are infinitely many solutions, everybody. But if you want to go with whole, just as an example, this would be 4, 2, and this would be 3, 4. Just as an example.